Well, so my name is Oscar. I'm from SES Valencia. I'm here with Adrian in the room. First of all, I want to thank you for the attendance. We are almost 40 person in the meeting from 11 different countries. So as you can see, there's a good mix of relevant stakeholders in the meeting. As you can imagine, the mix of the attendance was intention in order to have different points of view in the manual that we have prepared and that we're going to present you. Since in each country of Europe, there's a different methodology for the calculation of the energy performance certificate. The purpose of the work of country of Europe, there's a different methodology. So the idea of this meeting, this workshop, was to have attendance from all over Europe to have the different. The purpose of the workshop is to present you the EPC Assessor manual and get your feedback from it in order to improve it and apply the necessary changes to adapt to your needs. So as you know from the invitation that we send you, the workshop is divided in 4 different sessions. The first one being the introduction to the D2PC scheme that I will be presenting. The second one are the methodologies, the asset rating and operational rating. After that, we can have a brief break. The third one is the D2PC indicators, and the last one, the D2PC tools. Session 2 is going to be presented by Stavros and Phoebe. Stavros is going to present the asset rating methodology and Phoebe the operational rating methodology. The smart readiness indicators are going to be presented by Detlef from Cleopa. Human comfort and well-being indicators are going to be presented by Thanos from Hypertech. The energy and environmental indicators is going to be presented by Phoebe also from FRC. And lastly, the financial indicators are going to be presented by Milla from Demo. And the last session of the workshop, which is the D2PC tools, we have the web platform and the BIM digital twin, which is going to be presented by Stavros. And the last part, the WebHIS tool, which is going to be presented by Christos. Okay, so as one of the objectives of the project is to unify and standardize the EPC scheme in Europe, having different partners from all over Europe was a key factor. In this slide, you can see that there are partners from seven different countries. Okay, from Greece, we have CERT, which is the Center for Research and Technology Hellas, which is one of the leading institutions of Greece in informatics, telematics, and telecommunications. We have Hypertech Energy Labs, which specializes in optimizing energy consumption and analyzing real-time monitoring of power consumption data. ISEB, which stands for Intelligent Solution of Zero and Positive Energy Buildings, which is a linked third party of CERT that specializes in the scientific research around building smartness. And lastly, in Greece, we have also Geosystems Hellas, who are deeply involved in big data and machine learning techniques for European projects and grid projects. From Cyprus, we have Frederick Research Center, which is a leading research organization, and more specifically, the Sustainable Energy Research Group specializes in the state-of-the-art research of experimental and computational building physics and sustainable energy technologies. From Lithuania, we have KTU, which stands for Kaunas University of Technology, which I think a lot of people in the meeting know because there's quite a lot of people from Lithuania. From Germany, we have 2 more partners, Cleopa and Cenercon, both of them focusing in the energy consulting and in the improvement of energy efficiency of buildings. From Austria, we also have 2 more partners, the Austrian Standards, which is the recognized standardization body in Austria, and also the Austria Energy Agency, which develops strategies for sustainable and secure energy supply, provides training, and also is the networking platform for the energy industry in the country. From the Netherlands, we have Demo, consultants, which have three main core business: consultancy, software, and research, and support their clients with real estate information management. And lastly, from Spain, we have two more partners. The first one, UNE, which is the designated national standardization body of Spain, and SES, which is the world leader in certification, inspection, verification, and testing. But more specifically, my colleagues and I are from the Energy Efficiency Department and the European Projects Department. So after the presentation of all the partners for the project, we want to present you the 6 different case studies that we have at this moment. As you can see, they are in 3 different countries: Germany, Greece, and Cyprus. In Germany, we have 4 different case studies, one of them being a multifamily home with 6 apartments. Then the bottom left, it's a metal factory, and there is also 2 more buildings with more than 100 years old. In Greece, we have the smart house at 3rd. And lastly, in Cyprus, we have the Frederick University, that I think we're going to see some real data from that building. So before talking about the objectives of the project, we would like to present you the drawbacks that we have defined of the current EPC methodologies. We have detected 6 main challenges that are: the first one, that is limited information and data quality on the actual energy performance of the building. Why is this? Well, because the EPC usually is done in an early stage of the building, so it doesn't take into consideration the aging of the building, and also because there is a lack of data performance during the operation. The behavior of the user of the building should affect the EPC. There's also insufficient information to building users and limited user friendliness. I'm sure that most of you have had to explain to a client the EPC because they didn't understand it. There's also a need for harmonization of EPCs with the smart city concept and the integration of smart readiness indicators in the EPC. And the last 3 challenges that we found are the need for a human-centric certificate, as I said before, a more user-friendly EPC. There's insufficient software credibility and quality because there is a gap between the energy performance certificate and the actual energy demand. And lastly, there's data discrepancies due to the subjectivity of the EPC assessors. Regarding the EPC vision and objectives, we have the introduction and establishment of the concept of next generation dynamic energy performance certificate. And you could ask, why dynamic? Well, because it is recalculated frequently by taking real data from the actual consumption of the building, and it sees the evolution of its performance. We also wanted to define the drawbacks and discrepancies of the current EPC scheme, what we already did in the previous slides. We also like to integrate the smart readiness rationale into the building's EPC and include a novel set of environmental, financial, human comfort, and technical aspects indicators that can help the user of the building understand the importance of energy efficiency. We also want to introduce the BIM-based digital twins coupled with state-of-the-art IoT ecosystems for the real near-time asset and operational area assessment of the building. As I said before, this project aims to calculate or recalculate the EPC of the building with real data from the measurement system installed in the building. It will also provide improved AI-driven assessment recommendations toward energy efficiency and optimal comfort and foster energy-saving consciousness. The user of the building will get recommendations on energy-saving measures and also the potential economic savings by implementing these measures provided by the AI. And lastly, the implementation of intelligent operational data platform for the EPC. These are two mainly. The web platform, which will be used by the EPC Assessor to introduce some required data that can't get from the BIM file, and the EIS tool that mainly is going to be used by public authorities to control the EPC of a certain area and maybe compare its performance of the buildings of that area. So once we have the objectives of the project, we would like to present you the objectives of this workshop. So why you are here. And the main purpose is, as I said before, to get your feedback from the manual that we are going to present you in order to improve it and adapt it to your needs, to the needs of the EPC assessors. Okay. And lastly, I want to comment that if you have any questions of any presentation, after each presentation, there will be time, 5 minutes more or less, to ask questions. You can do it directly in English by raising your hand, or if you feel more comfortable, you can write it down in the chat box and then in your native language, and then we will translate it to English so the presenter can. Okay, and well, that's it for my part. I think now Stavros is going to present the asset rating methodology.
Thank you, Oscar.
So Stavros, I will. Okay, now you can share your screen.
Okay, so I will share my screen right now. And presentation. Now you see the black screen. Now the right one. Is that right?
Yes.
Yep.
Okay. Good morning to everybody. My name is Stavros Koltsios. I'm an associate researcher at the Center for Research and Technology LAS, and especially in the Information Technologies Institute. My presentation will focus on the methodology overview for the asset rating and the assessor's role in the new developed certification scheme. An overview of this session. Firstly, we will have an introduction about the asset rating, its definition, the current state, and the gaps of current national implementations. Then we will see our approach developed in D2EPC. And we will implement our methodology on a case study for the NZEP Smart House, which is located here in Greece and inside the campus of CERT. And then we will see the approach towards a holistic asset certification scheme, the assessor's role in the scheme, and lastly, we will have a short discussion. Within the presentation, I will pose several questions. You can either, because I can see right now, I can see raising hands and stuff like this. We will have a summary of the questions at the end of the presentation. So let's begin with the definition of asset rating. It is the calculated energy rating with actual data for the building, the as-built values, and a set of standardized values, which are they? The external climatic conditions, building and thermal zone uses, the operational profiles in each thermal zone, and the indoor conditions or boundary conditions that describe the operation of the thermal zone. Let's say the temperature or the relative humidity. There are several calculation methods for the asset rating, the quasi-steady state monthly method, the simple hourly dynamic calculation method, and the detailed dynamic calculation methods. In our approach, as we developed from scratch the calculation modules, we chose to proceed with the quasi-state monthly method. And so all the calculations are on a monthly step. And here is the first question. Which EPC rating scheme is used in your country, the asset or the operational? And which one do you prefer? I am looking forward for your answers at the end of this presentation. So the current stage of EPC's adoption in the European Union. EPCs right now are a mandatory requirement for the EU member states when constructing, selling or renting a building. Of the 27 EU member states, only 16 have adopted the methodology exclusively based on calculated energy consumption, the asset rating. The validity of an EPC lasts up to 10 years in most countries. And the question is, are the end users perceive it as an informative tool or just as a burden to construct, sell or rent a building? Right now, the identified gaps in the EPC procedures are focused on BIM documentation and literacy or digital logbooks absence in the process of EPC issuance. In the most countries, GIS information is not included. And there is also lack of environmental indicators, financial indicators, human comfort assessment, and also smart metering and real-time data are not utilized in the calculation procedures of EPCs in many member states. You can find all this information described and even more in our white paper D2EPC requirements survey, as well as in the publication that was made within the scope of this project in Climate 2022. As you can see at the top right corner of your screen. So, as D2EPC, we proposed some alterations. Firstly, for the faster building documentation, we propose the leverage of existing build documentation procedures. And our ultimate goal is to reach the digital twin, as it will be explained later. And why that? Because faster documentation means faster EPC issuance and lower cost of EPC issuance. Secondly, as the D2EPC, we think it is crucial to adopt a common European asset rating framework. Our approach is based on the European ISO 52000 series of standard published in 2017. And according to this standard, the development of the asset rating scheme has been based off. Furthermore, each European member state preserves the characteristic of its national methodologies, like climatic data, desired indoor conditions, or the definition of their reference building according to their national building codes and their minimum requirements. And also several information about the energy carriers like primary energy factors. And the question here is, do you think that BIM will actually help the EPC issuance process, or maybe it will make it even slower? And secondly, are European member states willing to proceed to a unified EPC approach, or they prefer to have separate national methodologies? An overview of our calculation tool is like this one presented in this picture. Firstly, the assessor gets the BIM file, and he or she may add several additional information. Then this information is passed and directed towards the asset rating core engine, where it utilizes the information stored in its databases about the operational conditions, the reference building according to each country, and the climatic data, as well as the energy carrier data. So the module makes the calculations and results to the EPC rating of the building. So let's have an overview of the calculations performed by the asset rating module. Firstly, we need to figure out the energy demand of our building. As for heating and cooling demand, we calculate the transmission, ventilation heat losses, the solar heat gains, and the internal heat gains to calculate the monthly values of energy demand for heating and cooling. Also, we calculate the energy demand for domestic hot water, as well as for lighting only in the buildings of the tertiary sector. It is not included in residential buildings. So we have the calculated values of energy demand per month. Then we take also into consideration the installed systems in the building to calculate the delivered energy, and we also take into consideration the installed renewable energy sources like PV installation or solar thermal collectors installed on the building. And then we calculate the primary energy calculation according to the national primary energy factors. A crucial concept throughout the whole procedure is the reference building. All the calculations that I have described in the previous slide refer to the actual or examined building. The reference building is an ideal building that has the same geometry, orientation, and uses as the examined building, the same standardized operational characteristics, the same climatic conditions, and predetermined construction materials and technical systems as defined by the national building codes or the minimum requirements. So all the calculations that have been described in this slide are also performed for the reference building. So we can have a reference to compare the energy performance of our examined building. Another procedure is the reference values. Let's say we calculate the energy performance, the kilowatt hours of our building, and compare it with a reference value. I would like to think what is the approach used in your country and which one do you prefer? So after calculating both the primary energy consumption, the total value from our actual building and the reference building, we divide the two values to conclude to the energy class of our building according to the table presented in the top right corner. And the resulted asset rating KPIs refer to the energy class, as I described, the primary energy per energy service and per energy carrier, the total CO2 emissions, and also some annual financial indicators are also presented for the end user to gain a better understanding. The implementation of our methodology will be presented on the NZEP Smart Home DIH. It is a two-floor building, mostly used. It is divided as its main core with orange color is residential, and there are also some office spaces in the green areas as presented on the right part of your screen. And also there is a non-heated space which is not taken into consideration for the calculation of energy demand. The building is equipped with heat pumps for heating and cooling with indoor VRV units. And there is also a PV installation of approximately 10 kilowatts installed on the roof and a solar thermal collector of 2.5 square meters. Right now, I'm presenting the comparison of our results with the results from the national Greek methodology. As you can see, in the energy demand and the final energy, the results are roughly the same. That's why we have managed to adapt our methodology and make it very similar to the Greek one. Even though I would like to highlight at this moment that they are based on different ISO standards. KENAC, the Greek methodology, is based on 13790, I think, and our standard is based on 52,000. Also, the primary energy, here we have some alterations, and in both cases, the resulted energy class is the highest score. In the case of KENAC, is A+, which is the highest, and in the case of our methodology is also A, which is the highest possible. There are two different, it is the same value in two different rating schemes. And right now we have to think what else can we add to the scheme, to the certification. Smart Readiness Indicator is something proposed by the EPPD, so it has to be in the new scheme. And also life cycle assessment is something related to the building's static information, so it can be an informative indicator. In the documentation procedure, digital logbooks can also facilitate the certification, as they provide a systematic and automatic building documentation and a holistic data model. And as I previously described, the end goal is the building digital twin. Also, we examined the building. Now we have to find a way to make it even better. So building renovation passports are a long-term, up to 15 or 20 years, step-by-step renovation roadmap. We can also leverage machine learning algorithms to make multiple strategic scenarios generation with all the market available alternative upgrade scenarios. And then after generating all the scenarios, we need decision support algorithms to guide us to make the proper renovation actions. How important do you think is the inclusion of LCA Kpis in an EPC, as the SRI is like a mandatory? And how skeptical are you about the automation of the EPC procedure and also the renovation proposals? And the assessor's role in the proposed certification scheme is going to be discussed right now. And no automation system can eliminate the assessor's role in an EPC certification procedure. As we have probably all learned in our university years, even though a simulation program can do much of the work, an engineer is vital to monitor the system and figure out when it may provide some wrong answers if it is given the wrong input. So the wrong input is mainly in the BIM model, so which has to be validated with on-site inspections and corrections of input data inconsistency, or even the BIM model, maybe it is not updated, so it has to be added several new information. The thing with BIM models is that they are not intended for EPC issuance. They are a very well-structured tool that we have in our proposal, but even though they can save a lot of time for the assessor and lower the EPC cost, the assessor's role in the BIM in the input of information from BIM models is also crucial. After inserting and validating and inserting all the right input data, the assessor is also responsible for the verification of the calculation results, the energy results, the KPIs, the EPC class, and the thing that, in my opinion, is the most crucial one is the interaction with the building owner, as only a human can understand the end user needs and provide a personalized guidance for increasing the asset's energy performance. The expansion of the EPC schemes only increases the assessor's responsibilities and scope and goals in the area of energy performance certifications. It doesn't eliminate him. So that's my part so far. Thank you for your attention. I will keep sharing the list of the questions posed within my presentation. And I would like to start with the first question.
Stavros, sorry,
yes?
there is a previous question from Alexander.
I'm sorry, I can't see my screen.
Sorry, he says that the difference in consumption from KNAC and D2 EPC, it's so significant, and if you can elaborate the reasons for this, and if you think that this also will lead to recommendations to the national authorities responsible for KNAC.
I'm sorry, I have to stop sharing to see again the question. Is it on the chat?
On the chat, yeah.
Yeah. Yes. Yes, Alexander, the difference is as we have searched very deep into this topic, there are some difference in the boundary conditions that we have assumed within the zones, especially for ventilation, and which we have managed to firstly to find them and then to make it to adapt the same values. So we have even more accurate results, even though they are not presented in this presentation. And there are also some difference due to the slight temperature difference. In our approach, as we tried to make a European approach, we have a unified data set of climatic external climatic conditions, which we have taken from JRC's PVGIS module. And right now, this is the most not error, the source of differences. I think I have covered your question. I'm No response.
Well, I mean, it's a complex question. So if
yes,
if that's the explanation, that's fine with me. But still, having such a difference would, for me, lead to something. So as a recommendations or some other approach, because it's not possible to have so many different call these estimations. What would the building owner believe? Which one should be used? There has to be some justification to choose one or the other.
I guess, and this is why we have to proceed with a unified European scheme, in my opinion.
Okay, thank you.
We have another question, Stavros, from Rui Fragoso.
Okay, how do you deal with NZEP or a future ZEP? Will the reference building, in case of NZEP, whose requirements reflect the performance need to achieve that level of performance? If so, this scale ratio presented in slide 11 adapted to that. No, okay. This scale ratio is only indicative from the ISO 52 series of standard. The scale of classification has not been. It is a much bigger topic that we haven't covered all of it yet, and I can't elaborate more on it right now. Of course, we will take NZEP and zero energy buildings or positive energy buildings into consideration in the final scale. And so this is adapt
Okay.
to that.
Thank
Yeah.
you, Stavros. I also
Okay.
agree that this is a complex topic I was raising, and it would lead us perhaps to another discussions outside the scope of the project. But thank you for your comments.
It is a workshop by itself.
Yes, I agree.
All right, so I think we can proceed to the questions. I would like to hear some answers also from you. So, any raised hands?
We have one.
I'm sorry, I can see. Rui Fragoso. Yes, please.
Yes, hi again. Let me just turn on the camera. So good morning, my name is Rui Fragoso from ADEN, the Portuguese Energy Agency. I'll try to go very briefly through some of the questions raised concerning the number one. In Portugal, we have a rating system based on the comparison exactly with the scheme you presented, a reference building which reflects exactly the building that it's being evaluated, but a virtual building, but a building that has changes in its components in order to fulfill the minimum requirements or standards. Basically, it's the same building, but in different conditions or standard conditions. And we also go through a reference building instead of values, as at least in the moment, I think this has proven to be more suitable for the building itself, since we do have a lot of different climate conditions that are quite different, and it's difficult to establish single values that would be, or rough values, average values that will be representative of the stock. Concerning including life cycle analysis or human comfort, I think life cycle analysis is becoming more critical, and we see that it will be useful to introduce some additional indicators like the ones presented in the future EPPD that already provides some conscious approach about life cycle itself and embedded carbon and etc. And human comfort for Portugal, it's quite reference. We're trying to develop a comfort indicator that would go into the first page next to the EPC label itself in order to provide information about how that building performs, just using the building itself without use of heating and cooling. As you know, in Portugal, the use of those heating and cooling appliances are quite low, and so most of the people rely on passive the performance of the building. Concerning BIM, I think there will be a space for BIM, an increasing space, perhaps for certain situations, bigger buildings, more complex ones, and more on new buildings. Most difficult to find sometimes information on existing buildings. So BIM, I see it coming from bigger to less complex buildings, and automation of EPCs, and I believe you touched on recommendations. Well, I think it could be interesting to provide a glimpse of the experts, not to forget specific areas that's shown to be areas of improvement of buildings, but it would be interesting to leave the necessary flexibility for our experts to identify exactly the kind of measures they think are necessary due to specific conditions of the building, although in terms of order or steps to implement them, and etc. So I would like to see, for my opinion, some flexibility left also for the experts, besides some automations that could be relevant to provide some highlights.
Yes, thank you for your answers. They're quite insightful. About the one minor comment for the fifth question, the road mapping, the renovations road mapping is only like to give some directions. The system does not eliminate the role of the assessor or the energy auditor in the buildings. Can I have also a comment from another participant from another country? No hands. Okay. Thank you. And I think we can, I will pass the floor to Phoebe to proceed with the operational rating.
Thanks, Stavros, for your presentation.
Thank you. One moment to share my screen. Can you see my screen?
Yep.
Thank you. So good morning from me as well. My name is Phoebe Zoe Georgali. I am an associate researcher in Frederick Research Center of Cyprus, and today's presentation is about the EPC calculation methodology for operational rating. The following sections will be presented. The elaboration of D2EPC calculation methodology concerning the operational rating. Secondly, the development of energy indicators, the presentation of operational indicators, the research and study regarding the FRC pilot case study, and at the end we will have some questions and answers should you have any. The first part of the presentation will be posed as a question and answer way. So the first question is, what is an asset and what is an operational methodology, and what types of ratings are available currently? The asset rating module is a dedicated tool for the calculation of the asset energy performance rating of the building under investigation, and the information for the energy model of the building can be derived from the building's BIM file as well as through on-site inspection, as Mr. Kolchus before presented in detail. The core process for the EPC's calculations lies in the calculation of buildings' heating and cooling loads with the use of Building Energy Performance Simulation (BEPS) tools. D2EPC, with the use of these BEPS tools, examines energy performance calculations based on the actual energy consumption of the building, known as well as operational rating. The importance of employing the operational rating methodology approach for assessing the energy performance of buildings is emphasized for each enclosure in the dynamic EPCs. In this slide, we can see that there are two types of rating, the calculated and the measured. The first one is the asset rating, and the second one is the operational rating. These are according to the European standard 15603, as well as the 52000. And here we can see that the ratings, the building energy rating description is regarding the measured energy rating, the calculated, the tailored, the standard energy rating, and the design energy rating, which have more or less differences in the way of input in the standard input data and the measurements that are measured for the rating calculation. The second question is, what type of evaluation is D2EPC, asset or operational? Concerning the D2EPC project, it's known from its beginning that aspires to deliver the next generation of dynamic EPCs for the operational and regular assessment of buildings' energy performance through a set of cutting-edge digital design and monitoring tools and services. In the context of D2EPC, integrating smart meters, actual performance related data and activities profiling into the building's digital twins will be presented. The third question is, if D2EPC is an operational rating, why should the asset assessment of the building be conducted by a D2EPC tool? This is because the asset rating, the operational indicators are also taking in accordance the asset rating, and from that point of view, subsequently build upon actual data and the digital twin concept to calculate the accurate and the actual real-time energy, environmental, financial, and human comfort indicators. So we use the asset rating and we build on this for the operational rating. The fourth question is there a pan-European methodology for asset rating? Yes, and as Mr. Kolchos presented before, there are a lot of European standards regarding the asset rating, as we can see in this slide. And again, the D2EPC scheme will be based on the relevant European standards and the Energy Performance of Buildings Directive in order to allow for a European-wide deployment. And the relevant deliverable will be delivered on time regarding the asset rating as well as for the operational rating. The fifth question is if there is a pan-European methodology for operational rating. The answer is no, and that's why we are here to talk about operational rating in the D2EPC project. The updating of current standards towards dynamic EPCs is under this under work, and specific CEN standards are in procedure to be committed under the D2EPC project, and we would like your vote on that regarding the the working group 5, which will be announced from the CEN Committee of Standardization. The 6th question is if all EU member states apply the operational rating. Of course, they do not, as the research findings presented. 11 of the 27 European member states are using or either completely or with combination with asset rating. They have also operational rating. And regarding to that, the specific energy performance class of buildings operational rating methodology will be delivered as well with the asset rating. The last question is what topics should be addressed in EU-wide operational rating methodology. These are if the operational rating apply for all types of buildings or only for certain types, if the total energy consumption of buildings considered to issue operational EPCs or are individual energy consumption streams considered as heating, cooling, domestic hot water, etc. What is the reference value based on which the energy class of operational ratings is delivered? Either are typical values or the average consumption values of buildings over a certificate period. What is the frequency of issuance of operational EPC in each European country? And how is the energy consumption measured to issue operational EPCs in different countries? And who is in charge of installing this equipment? Either there are the EPC assessors or the utility companies. In this slide, we can see that from the D2EPC project, the energy measurements, the energy indicators were presented, and simplified energy indicators such as total energy over area per annum cannot describe thoroughly the energy performance of a building. So the D2EPC energy indicators are intended to present gaps in building performance indicators that can be utilized in conjunction with the increasingly accessible system level data from the growing use of sensors and meters in buildings to quantify and analyze energy performance. So we have the total power, heating and cooling, lighting, and the electrical appliances. As denominator of this part, we have the occupancy hours, occupancy concerning the hours of occupants, the area, and the volume. The methodology used for creating energy indicators values is the operational rating, and the calculations are based on the data retrieved by the building's regular measurements, where these are available. Implementing appropriate energy and environmental building evaluation techniques on a wide scale is required to stimulate market demand on sustainable practices in the built environment. Here we can see the example of the total power numerator indicators. The operational rating scheme is used for the calculation, and a complete list of 25 data results from 4 categories, which you can see in this slide. And these energy indicators are a result of measurement values, where these were available, retrieved by the building automation and control systems, as well as by smart meters. It is noted that the operational assessment of heating and cooling consumption, as well as domestic hot water consumption, are conducted per energy carrier, And in those cases that there is a sole energy carrier, either for heating or cooling or even for both, the indicators specified per carrier are equal to the indicators specified per total energy. Here we can see the 25 data results for the energy indicators concerning the power consumption of the building, the cooling consumption, as well as the lighting consumption and electrical appliances energy consumption. And here we continue with the FRC pilot case study information. The building introduced in this case study is a multi-use building with quite a diverse set of spaces, systems, and assets. The entire new wing building covered is divided into 3 separate zones, monitored in detail, and the entire building is also covered in terms of energy monitoring, providing a complete data flow that fully depicts the building's status. The building constructed in 2017 and is operating during the usual office hours as a university, as it includes offices as well as seminar halls. So it's in the non-residential category. Here we can see that the occupancy, the surface area, and the volume per floor are presented in this table. And in 2021, indoor condition measurement devices for temperature, relative humidity, and CO2 were installed, as well as for power meter data loggers. And from June of 2021, and for 1 year now, 1 year was completed of actual real-time measurements, has been conducted. Here we can see the HVAC system installed in Frederick University Newwick building, which is a variable refrigerant volume air conditioning system used for both heating and cooling of the 2 occupied floor spaces. And here as well we can see where is the installed lighting, which has 2 system types in the 2 floor spaces according to their use. In this slide, we see how the documentation of indicators was done. It was based on the real-time measurements of the FRC pilot case, and it was related to heating and cooling, lighting, and electrical appliances indicators. They were documented in annual, biannual, and per semester time step. We will see later on the graphical representation of these time steps. And these indicators have been calculated in relation to the occupancy, the surface area, and the volume per floor of the building, as we saw in the previous slide. Here we can see the graphical representations using the Python language coding program. And here we can see the heating and cooling energy per floor area for all the 3, for the ground floor, first floor, and second floor. The outdoor temperature indicators per each month we took from June of 2021 till June of 2022, but here there are some indicative graphical representation for summer time, June and July, and for winter time, and we can see their differences. Here we can see the relative humidity and indoor temperature for the second floor and how this is depicted from again for the whole year. And here we can see the carbon dioxide and indoor temperature again for the whole year for the second floor. Here is represented the total power consumption of the building per each floor. And the time step was per hour, but here we presented it in per month. So to have the whole year. The energy classification of Frederick's pilot was conducted in accordance to the building stock as reference method described in the European Standard 52003, which was delivered in 2017, and more specifically to Article 10 concerning the EPB rating. The assessment of the Cypriot building stock was conducted in accordance to the minimum requirements for Class A buildings, according to the competent authority in Cyprus, and also the D class, energy class consumption of the building stock in Cyprus was based on the GRC technical reports. So, taking in consideration these two energy classes and with linear interpolation, we achieved to have the energy rating class for residential building typologies, operational rating, of course, and also for non-residential buildings. We had a time step, and having the A energy class and the D, we found the in-between classes. So this case study building for the FRC, as it's private offices, and it has almost 128 energy class. I mean, kilowatt hours per volume. It's we can see that it's in class B. It's indicated in class B. So that was my presentation for today for the EPC calculation methodology for operational rating. And should you have any questions, please tell me.
Thank you so much, Phoebe. I don't see any questions on the chat. Maybe if anyone wants to ask something now.
No, nothing.
It was clear.
Okay, thank you.
Okay, so if you want, we can make a brief break now, 5 minutes or so, and then we can return and start with session 3. Okay, so let's continue if you want. And if you are back.
Yes, we are back.
Okay. Detlef, are you there?
Yes, I'm here.
Okay. So now we are going to see the Smart Readiness Indicators, the SRI, which are going to be presented by Detlef from Cleopa. So when you want.
Oscar, just a short comment. If the participants want to have a question in the national language, please write it in the chat and the colleagues can translate it if this is a problem, if people have.
Yeah.
Thank you.
So I hope you can see my screen, and I will transfer this over here.
Yeah, okay, yeah, now.
Coming in sensor, I think it's F12, right? Oops. I'm sorry. 1 second, please. Oh, hang on. Ah, yeah. So, how can I so let me see this one here. So, is that good?
Yes, it's okay.
Wonderful. So, I just need to turn my screen here. So that I will be better closer to the camera because of my second screen. So, welcome. I will tell you a little bit about the this is a fight. I will tell you a little bit about the Smart Readiness Indicators analysis for EPCs, which we are doing here in the D2EPC project. I need to, I want to collect you and tell you a story back from, I think, 2019, before COVID. Then I was in the late part of the year. I was in Brussels for an SRI meeting, Smart Readiness Indicator. And first I was just generally interested because I thought, okay, if we have like some digital path for a building, then we might have new ideas how to do new services, how to improve energy efficiency, how to understand resource usage of buildings even better. And so there in this really bad weather, I went to Brussels, and then there was a comment made by the presenter there that the people from the Smart Readiness Indicators were asked to do an impact analysis for the European Commission for the years 2020, 2030, and 2040. So for me, as some kind of business person, as a consultant, as some kind of energy contractor, I thought this is exactly where I need to have an eye on. If the EC says there is an impact up to 2040, then this is for sure the thing I have to look at. And this is why we are also so much interested in SRI. And I hope you're also looking into SRI with this eye. So, yes, in 2018, you just see that the European Commission adopted the Smart Readiness Indicator concept, and they put it even into the Energy Efficiency Directive for buildings. What they want to measure is the intelligence, the smartness of a building system, and so that energy efficiency, energy savings can be adapted, can be improved in the building sector. And as you can imagine, these digital services, digital indexes are really new and so far unused. It is fully new and still in progress, and we're happy to contribute here in this project. Okay, so here you see some of the, I think you see the main indicators and domains for the Smart Readiness Indicators: heating, cooling, domestic hot water, controlled ventilation. Well, you will see it yourself. But what is really more important is the next slide, which I will show you. Hang on, I just need to put it out on my paper here. Yes. So here is really how you can calculate a Smart Readiness Indicator for a building. So you have a wonderful matrix, and all consultants or all planners, and we are just also becoming consultants for sustainable buildings here in Germany. We just need to collect all these indicators as well: human comfort, convenience, health and well-being, energy efficiency. I think the Smart Readiness Indicators gives us really a toolbook how to improve the building and building data in a fully new way, which has not been seen so far. So what are we doing with the SRI analysis here in D2EPC? We want to establish a framework and the scope of the SRIs in the next generation EPC. Of course, we're talking really about the things coming up in the future, and we're just scratching at the initial parts of it, and we are testing, evaluating how to adapt these issues from SRI coming to the new dynamic EPC field. So for this, we of course need to be transparent, I think this is really the important thing, transparent and sustainable procedures, which will define the guidelines for the realization of the SRI certification. And maybe if you have more time or so, then we could also discuss about the different ways, different ways A, B, C of the smart readiness indicators, but you can also look this up as the SRI page. And one of the objectives of us is also to have a direct linkage of the SRI to the dynamic EPC in the future. And so that it is, as all of you, I think, or the majority of you are EPC assessors in your countries, that you will be able to add even new services to your clients. So if you see, when you have regular EPCs to assess, then of course this is a standard market so far. But if you look here in the next generation of services which you want to provide, then of course it's very important to look both at the SRI and the dynamic EPC in the future. So let me tell you a little, yes. I will briefly tell you also a little bit about the smart readiness indicators analysis and the 3-step methodology. So first, what we did and what we still do in the project is we look at the current SRI methodologies and of course the issuance of SRI certification. Yes, in the end, everybody in Europe should have the same result for the same building in the same environment. Then we are looking also at the legal framework and we are constantly monitoring the official SRI documents and reports. Then we look into the building automation and control systems and SRI data. So we just match these things. The EN 52000 or 52000, the energy performance of buildings has of course specific parameters which need to be adapted in order to fulfill the norm. And so what is part of our activities here of the methodology is to match these values. And of course, third step is to resume and develop guidelines for the SRI integration into D2EPC. This is, so to say, the highest TRL, the technology readiness level, what we can achieve within D2EPC. So we have the development of minimum requirements for BIM models. And we are seeing now that there are some challenges, of course, from the BIM literacy and of course the definitions. And so we try to improve for the benefit of all following projects. What will happen? How can SRI be adapted in this context? So we are employing the SRI, the smart readiness indicators, also in the next generation BIM-based EPCs in the IFC schema. I don't know, I'm not sure how many of you have worked with IFCs so far or with BIMs. And I think for me, it started about 3-4 years ago when my son wrote his master thesis about BIM. So for me, this was like, this is also as important as SRI maybe, or maybe more important, because for some building parts in Germany, it's already mandatory for public sector building. So here we have this, first we are doing an IFC digital twin BIM file. Then we are identifying the SRI data which are already included in the IFC schema. This is our input. Then we do our SRI calculation as it is, or maybe we need to improve it even. And we have the output, which is then the SRI indicator. What is done? What is the benefit of this? Is yes, we can use the D2EPC platform for such things. And then you see down there this very small note here, the identification of SRI data not included in IFC schema. There we need to develop, of course, some calculation procedures for the output and also as a contribution for the SRI indicator. In our BIM-based EPC in this IFC schema, we found 9 SRI domains and 54 services included in the SRI scheme to be used in the EPC calculation platform. So here is just these numbers. If you see such things, then of course you can always see. And I will give you, of course, also one example. I think it's. Oh, I'm sorry. Now I'm faster in my slides than in my presentation. I will give you some example of that also, how these SRI metrics are done in 2 more slides. So this is, if you compare this slide here, and if you look in this slide here, then you see already quite a few quite a few parallel systems which can be done here. So here we have the staging of hierarchical levels of building automation and control systems. First thing, of course, you can just manage what you can measure. So we have sensors, actuators, and equipment, which is on the field level. So in the building level, so to say. Then we have the bindings and the data points. So a while ago, we were as Cleopa partners in a project called Cyber Physical Systems in buildings. And this was exactly the point where we needed to find, where we had a lot of challenges to connect these sensors to platforms in general. And this is also one important aspect which we are addressing here in this context. And what is the next level, third level, of course, and is then the management level, where you can really control and manage the set point, for example, or as you have it now, I think, with this energy poverty discussion, at least in Germany, we are discussing to lower the temperature of domestic hot water, for example. Yes, then you just are changing the set points for this. And this is then a good example for the management level. And as you can tell, for the smart readiness indicators, if we have a remote control for these set points, this is much easier to be done and could be much more flexible than it is. Then if it is done manually, some technician has to go there, has to come back. This is and a lot of errors optionally occurring as well. So here you see already some of the benefits. I'm sorry. This is my phone. I'm sorry. So of this, what we are doing here in the SRI context of the EPC. So let me see. I'm still good in time, or have I overdone my time?
Yeah.
Okay. So here I show you some metrics of the SRI, the lighting example. So first is the indicator name, and you know these from all these normings and evaluation systems itself. First you have the indicator, then you have the indicator description, which is in this case occupancy control for indoor lighting. Of course, there's no real unit to say. So maybe we should have some others. Category is of course SRI, and this is. Let me. So now it's better. I'm really sorry. Then we have these calculation procedures where we define what is giving you what is level 0, what is level 1, 2, 3, and 4. No, here it's just up to 3. And then you have the input data is then on the right hand side, which you can see is the stuff which we will include into the calculation of the smart EPC platform. So then you see here, of course, the mapping of SRI metrics and IFC entities. And this is, of course, a little bit more for the experts of Cleopa, Christiana and Magdalena, which have much deeper insight into these metrics, of course. And what are the conclusions of the EPC IFC-based SRI analysis? There is no easy way of the current EPC assessment to have an extraction of the smart readiness indicator. This is a disadvantage on the one hand, of course, but if you have a fully new product, if you have a fully new service, or a certificate in this case, then you of course need to expect that some things will need to be fully new developed as well. So so a limited number of information can be extracted, and you see this list there. And in the current change, a significant number of functionality levels are not addressed in IFC schema, but this is of course obvious because IFC has a different scope and a different objective to do this. So yes, SRI cannot be IFC, nor IFC can be SRI. And the information supported by the current IFC level is limited to the field level supporting the definition of devices and wiring relations, and disregarding the logical and operational aspects, such as control loops, bindings, or configuration management. So then, second page of the conclusions, which we have, and this is also my last slide, I think. Here are some of the features which can be defined in IFC for the SRI screening, which is heating, presence of heating system, emission type, production type, domestic hot water, cooling, controlled ventilation, dynamic envelope, of course, electricity, how much renewable, and steerability. And but the electric vehicle charging is not yet supported, but will be for sure in the future. The minimum modeling requirements were presented for specifying the first SRI level. So, of course, if in the SRI will develop also into different levels over the time, and of course, then you will have also more requirements. But here we are addressing the first level of SRI. And the use of IFC for automating the screening. This is the very important thing. Still needs some user-specified input, but of course a lot of things can be done already with the D2EPC platform. And this is where I can say that thank you for your patience. And if you have any questions, I'm happy to answer where I can, or just ask my smart D2EPC partners to support me on this case. Thank you.
Thank you so much, Detlef. Okay, so I don't see any questions on the chat.
Thank you.
Okay, so we can continue. Thanos is now going to present us the human comfort and well-being indicators.
Thank you very much, Oscar. Let me share my screen and tell me if everything goes smoothly. Give me 1 second, please. Okay. Have you seen my screen?
We can see it, yeah.
Okay, yes. Perfect. Okay. This section concerns the human comfort and well-being indicators incorporated in the D2EPC. In brief, I will make an introduction about our selections and dive into the framework as it is, the hybrid approach that it was followed, the personalized comfort profiling engine, which plays a significant part in our assessment, some evaluation methodologies for the comfort and well-being assessment, and then we will look over the indicators and show you some preliminary results. I would like to begin with a comparison between the current methodology and our approach after an extensive research on European and national standards and other certifications and frameworks to see how they assess the comfort and the well-being of the occupant. We have identified methodologies that at times expect multiple inputs in terms of measurements or feedback from the occupants. A typical example is the Bmvpd methodology for anyone who is familiar with, or the adaptive thermal model that is introduced in well-established standards like the ASRAI 55, the EN 15251, and the levels framework that recently is growing a lot around Europe. Our concern is that such measurements are not always technically and economically feasible to be delivered in pilot installation due to several limitations such as budget, or occupants' disagreements, etc. Furthermore, we consider it much intrusive to alert the occupant and to request from the occupant to provide us info that would help us assess the comfort environment of a space. So we wish through our approach to eliminate such discrepancies and initially extract these user behavioral profiles that ultimately influence the building's dynamic performance from the scope of the occupants and comfort and well-being. We study within our approach, we study user historical data to identify preferred boundaries of system operation in terms of several environmental parameters addressing the indoor conditions, the indoor ambient conditions. Where this is not relevant or applicable, we extract the recommended boundaries from the literature, and based on these boundaries, we constitute this set of human comfort and well-being indicators with our goal to gain maximum information from minimum resources, because in real-life scenarios, the deployed IoT devices are not they requested are not always requested and are not smoothly operating always due to several problems or malfunctions. So we need to have a framework that gains maximum information from what we already have. So concerning the human comfort and well-being indicators framework, the D2EPC, it is constituted on the basis of 3 indoor environmental quality pillars: the thermal comfort, the visual comfort, and the indoor air quality. Those comfort profiles or boundaries of operation, we utilize a purely measurement-based approach in order to be performed on building data streams and extract these profiles. There's personalized boundaries. The personalized boundaries are calculated based on previous behavior, and previous behavior we mean trends and patterns that are identified in the users presenting data with the usage of the specialized comfort profiling engine. And we achieve to calculate these user profiles in a purely dynamic, data-driven, and unintrusive way. And finally, our indicators are based on well-defined, measurable environmental performance metrics, realistically measured with IoT equipment that will be deployed in our pilots. We utilize some long-term evaluation methodologies to translate these metrics and boundaries into performance indicators, and the D2EPC architecture delivers a calculation engine that will take over the calculation of the KPIs and deliver it to the end user. Here you have a graphical representation of what I was describing earlier. The 3 environmental quality pillars: indoor air quality, thermal comfort, visual comfort. The vectors correspond to the boundaries, either extracted from the literature, for example, in the well-being case, the well-being assessment case, and where it's applicable, we use this comfort profiling engine. Or we use straight boundaries from the literature for the comfort and thermal visual comfort cases. All these, they take as input the real-time data in the calculation engine and delivers the results. A few words for the personalized comfort profiling engine. As mentioned previously, it analyzes the collected data from the pilot infrastructure and identifies the occupant's comfort boundaries. We imply, through the usage of this engine, we imply that the optimal visual and thermal conditions for the occupant are detected by her and himself. By this, we mean that we consider that the user, the occupant, will tend to specific actions that will alter the indoor environment, the visual and thermal indoor environment, and in order to adjust it to his or her likings. So this automatically means that all those user profiles extracted by data must refer to regularly occupied spaces by the same occupants in order to be precise to whom we address these boundaries. And these trends and patterns in the user pass data are examined, are used and put into as inputs to our engine that comprises of several data manipulation and machine learning algorithms for the classification, and they ultimately define these comfort boundaries. As I said before, we begin with the metrics that we obtain from the literature, well-defined measurable environmental parameters. We define the boundaries either from the literature or from the personalized comfort profiling engine, and this information is combined with this long-term evaluation methodologies for the comfort well-being assessment in order to deliver an indicator that is able to monitor the system progression towards the visual, the visual, thermal, and the indoor air quality. In brief, we use the time out of range, which simply calculates the percentage of hours during which the occupants are out of comfort for a specific period of time. The degree hours, which is the same calculation a step further by adding some weights that address how much the indoor ambient conditions deviated from the recommended or predefined calculated boundaries. And the last one is the fruity period of indoor environment, which reports the percentage of hours for each level compared to the total hours of the period of interest, because some of the recommended boundaries extracted from the literature are expressed in limits categories, and we need to see how our hours of occupation in our building of space of interest are expressed through these limits. With all this combined information, we managed to set 5 thermal comfort indicators. These indicators focus on the indoor dry bulb, or the well-known air temperature, and the indoor relative humidity. Both are well-defined metrics. They can be measured with relatively easily with IoT equipment, which is available and cheap. And we further included two indicators that are based on 2 thermophysiological parameters, which assess the thermal comfort environment as a combination of the air temperature and the indoor relative humidity, which play a significant role in the thermal sensation of the occupant. In the visual comfort case, the assessment, the literature review showed as a result that the measurable metric, well-defined with relatively cheap and IoT devices, it was the indoor illuminance. The indoor illuminance can be measured inside the space. There are several levels from the literature that deliver specific limits, specific values for the illuminance that should be maintained, based on the visual, or the nature of each visual task. So it has applicability on different building space typologies, and in residential cases, or in cases where we have the spaces regularly occupied by the same occupants, we can utilize the personalized comfort profiling engine for the visual comfort case. And for the air quality indicators, a complete air quality assessment expects a multitude of parameters that most of them concern gas concentrations that are harmful, at higher concentrations are harmful for the human respiratory system. This is, of course, not always feasible to apply in pilot cases, especially in the residential cases. So we have segmented the air quality indicators into main and complementary. based on another techno-economical feasibility analysis that was performed in order to see what we can purchase as IoT devices and what is already measured in the D2EPC pilots, that because the majority of them are already equipped with IoT infrastructure. And we ended up that the carbon dioxide indoor concentrations, the volatile organic compounds, and the particulate matter of 2.5 diameter were the main indicators that will be calculated for the D2EPC pilots. Here you have some preliminary results for the human comfort and the well-being indicators in the thermal comfort case. Here you can see two comfort graphs, as I characterized, which deliver areas of discomfort or no discomfort during both the heating and the cooling period. Here we have a scatter plot of indoor relative humidity and indoor air temperature. So we have pairs of measurements aggregated on an hourly basis in order to check in what areas they allocate to. It is worth mentioning that both in cases, we have two separate cases, the hypertext test bed, which is equipped with several IoT devices delivering several types of measurements, and the NZ Smart House, which is one of the pilot cases of the D2EPC, in which there are also multiple IoT equipment installations that deliver the measurements that we need to acquire to calculate the indicators. One comment I would like to make on the comfort graphs is that this assessment using the Humidex, which, as I said earlier, is a thermophysiological parameter which addresses both the combined effect of the air temperature and the relative humidity. We can see these areas for the cooling period, especially because the relative humidity is plays a significant role in the thermal sensation at higher values. We see that the tolerance of the comfort the tolerance in higher air quality, air temperature is deteriorated as we have higher values in relative humidity. So we can be more specific about which events correspond to comfort and which events correspond to discomfort. In this table here, we present some indicative results for the two spaces. We calculated these indicators based on the ASRAE 55 boundary for the indoor air temperature, which is about spanning from 19.4 to 27.7 degrees Celsius. So we calculated these indicators for the space, and this thermophysiological indicator, the Humidex level, delivered the results for the hypertext test bed of 92% of the time we have no discomfort in the space, and for the NZ Smart House, for the 94% of the time we had no discomfort. And some next steps for the human comfort and well-being indicators within the D2EPC. Firstly, we need to finalize the equipment IoT installation of the D2EPC pilots, complementary to their existing IoT infrastructure, as I said before. Further, we will examine the thermal visual and air quality indicators results for all pilot cases during the project's demonstration period till the end of the project. The KPI calculations will be integrated in the D2EPC systematic architecture and ultimately deliver the results to the end user via user-friendly interfaces as part of the dynamic energy performance certification. Thank you very much, and I'm at your disposal for any questions.
Thank you, Damis.
Maybe I was a bit fast, sorry.
Yeah. There's a question from Gerfried. I think he's asking if there is some factor or indicator for natural lighting. I don't know if you can see the chat.
Yes, I am reading the question. Give me 1 second, Oscar. Thank you very much. Okay. The natural lighting is incorporated in the analysis. We take illuminance measurements. So the illuminance measurements from a space might come from either natural or artificial lighting based on the hours per day, of course. During the night hours, we completely refer to artificial lighting. So this is an indication of a connection between light, visual comfort, and how could I put it? And energy consumption due to the lighting appliances. In order to assess the artificial lighting, the natural lighting, the methodologies utilized or delivered within standards are not that applicable. We have made this literature research, and we ended up that these methodologies are not always applicable concerning the glaring effect or the outside view, which is highly intrusive for the occupant, because the occupant herself needs to sit down and deliver us results to how he or she feels like with the incoming light. So this is highly intrusive, and this is out of the scope of our assessment. And I can see another one question. I will take it over, Oscar. Is there differentiation between lighting standards for office work and residential rooms? The only differentiation that we utilize from the national standard EN 12464. We obtained some illuminance levels that they are tailored to the visual tasks. So we have based on the space typology and the type of activity that takes place in the respective place. There are several specific illuminance levels that need to be maintained in order to to deliver to the occupant the optimal visual conditions. For example, for which is quite relevant to our work, the data analysis procedures that request some coding, etc. The standards propose an illuminance level of 300 lux. So these levels are utilized as boundaries for the calculation of the KPIs for the visual comfort. I hope. In the residential cases, we can, if we have sufficient data and quality data, we can utilize this comfort profiling engine and check how the occupant himself, herself, maintains the levels of his preferred illuminance. Hope this answered your questions. Thank you very much. You may proceed, Oscar, to the next.
Yeah. So now Phoebe is going to present us the energy and environmental indicators.
Can you see my screen?
Yeah.
Thank you. Once again, I'm here. The last presentation of me for today. This presentation is regarding the energy and environmental indicators. In this, the following sections will be presented. It's the energy and environmental indicators analysis for EPCs, the development of environmental indicators, the definition of the required input and the design building elements, the Gradle-to-Gate Lca analysis results that concerning the Frederick university building. And in the last, if you have any questions, I will be pleased to answer. The sustainability assessment constitutes an internal aspect of the energy analysis of buildings. And despite the fact that numerous methodologies for assessing the sustainability performance of buildings are developed as of today, circularity indicators are still not integrated into the information provided in EPCs to building owners and users. The D2EPC project aspires to develop a set of environmental indicators which will enrich the building sustainability assessment. The novelty in the field is based on the fact that the information required for the extraction of these indicators results from BIM documents. And here, later on, will be presented the D2EPC approach on integrating sustainability and life cycle indicators into EPCs. Regarding the D2EPC approach, the proposal of LCA-related indicators which demonstrate the environmental performance of buildings for the introduction in the next generation EPCs. We have also the implementation of a comprehensive literature review on the LCA of the energy performance of buildings, the type and functional units of the LCA indicators for EPCs to be used. Third, we have as well the consideration of the required input and associated output resources for the calculation of the selected indicators in the D2EPC platform. It's the definition of the calculation procedures, selection of calculation procedures for the LCA indicators by knowing what the input precisely is, whether it is included in BIM software or not. It is the integration of the LCA methodology in the whole range of services related to the construction industry and the EPC process. As well, the D2EPC approach concerns the observation of the environmental footprint for each construction material and its category of the structural element. There were drafted 17 environmental indicators, which we'll see later on, in terms list, which are asset indicators and may be calculated through the combination of materials bill of quantities derived by a BIM document and buildings materials EPDs. As well, we have concluded under the D2EPC project in the drafting of 25 energy indicators as we presented earlier, which can be employed as operational indicators. It's the examination and identification of existing BIM tools in the BIM software. And last is the definition of innovative aspects and drafting of a list of flags and deficiencies of current BIM documents regarding the information needed by LCA for generating data exchange formats to share information and how this could be enriched. In this slide, we can see the concept of sustainability assessment of buildings according to the European standard 15978, which includes the environmental, the social and economic financial assessment and indicators. The work program of CEN 350 includes the standards of regarding the sustainability assessment of buildings and the assessment of environmental performance, social and economic performance, the environmental product declarations, and also the 15942 standard, which have technical characteristics and functionalities. Sorry, someone has their microphone. Here we can see the LCA methodologies that are used throughout the world, but we use the SML methodology, which is the most appropriate for our for the work conducted under this project. And here we can see the impact categories and pathways covered by this methodology, and which are the inputs, let's say, and what have as the outputs, which is the damage to human health or the loss of biodiversity, and the impact categories concerning this SML methodology, the climate change, the ecotoxicity, the acidification, etc. The development of environmental indicators was accomplished with the literature and scientific assessment of existing tools and methodologies for LCA. According to these standards, we can see in this slide. As Levels is the most recent European approach to assessing and reporting on the sustainability performance of buildings throughout their entire life cycle. This standard was chosen following this activity. The development of the D2EPC environmental indicators is based on the level scheme, as we said previously, which is the European Sustainability Assessment for Constructions outline. Levels is the most recent European approach to assessing and reporting on the sustainability performance of buildings, correlating the effects with European sustainability goals. Using existing standards, the Levels approach provides a shared identity for sustainable development, offering a foundation for quantifying, analyzing, and understanding the life cycle, and targets a variety of circularity features, delivering indicators that can better clarify how to expand the functionality of the building. It is also a helpful framework dedicated to enhancing environmental performance and resource utilization, as well as lowering the built environment's influence on global resources. The usage of real-time data collected from the development of the energy indicators for EPCs is significantly contributed to the maximization of the energy savings and the achievement of carbon reduction of the buildings, as well as complementing the SRI's social and economic indicators for the issuing of truly sustainable EPCs. In this slide, we can see that Levels standard aims to provide a general language of sustainability for buildings, and this common language should enable actions to be taken at the building level that can make a clear contribution to broader European environmental policy objectives. In addition, the Levels framework aims to promote life cycle thinking, and it guides users from an initial focus to individual aspects of building performance toward a more holistic perspective, with the ultimate aim being the potential for wider use across Europe of life cycle assessment and life cycle cost assessment. In the new wing pilot building, the Lca Analysis and results were extracted for the environmental indicators defined by the Levels database. The D2EPC includes a set of indicators that are related to the environmental and energy performance buildings, the importance of employing LCA methodologies for the efficient energy design of buildings and for enabling the parameterization of its embodied energy and primary energy demand are highlighted for their inclusion in the dynamic EPCs, and it is mainly addressed to relevant stakeholders as well as to practicing engineers and EPC assessors, anticipating to implement the principle of D2EPC project in building certification. The energy and environmental D2EPC indicators, which demonstrate the environmental performance of buildings, are proposed for their introduction in the next generation EPCs. And here is presented the Lca analysis, how the material is extracted, transported, constructed, and deconstructed at the end of their life. The extraction of the Lca results of the environmental indicators for a building through a BIM file, is presented in this slide. The results are extracted based on the environmental indicators of levels standard. Through this analysis, the values of the environmental indicators depicted above are shown in detail for stages of construction materials, transportation to site, construction installation processes, and the end of life, as well as the total values for each indicator. As values result, the environmental footprint for each construction material and each category of the structural element is observed. Here we can see that the Lca levels tool was used in the assessment, and a complete list of 17 data result terms are presented in this table as well as in this one. It's the continuation of it. These environmental indicators are asset indicators, as we said earlier, and may be calculated through the combination of materials built of quantities derived by a BIM document and buildings materials EPDs. Indicatively, we see climate change, eutrophication. Here we can see life cycle global warming potential, bill of quantities, materials, and lifespans, and the rest of the 17. In this slide, we see that this procedure was used to export the Lca results using the one-click Lca software of the environmental indicators for the pilot building. According to the software database, the parts of the building were designed and given the possibility to integrate the information of real data concerning the materiality of each structural element, volume, cost, features, etc. It was designed based on initially on Revit design tools, and afterwards the Lca analysis was conducted with the one-click Lca. The general procedure extract Lca results through a BIM file were based on the environmental indicators of levels in compliance with the European standard 15978. And the design and construction of the building envelope has taken into consideration all the aspects that ensure safe and energy efficient construction. The BIM materials were matched with the Lca library materials, and the information of the quantities and the type of material were transferred for the needs of this document to the software. All results of the indicators were received via tables and graphs, and here we can see the list of building parts and the BIM software database. The attributes of each structural element were defined based on structural materials and its characteristics. And in the case of Lca analysis, the type of structural element, its materiality, thickness, and volume were needed. So the analysis of Lca was conducted through a plugin. BIM attributes were matched with a library of materials, as I already said, and then all the results of the indicators were received through this assessment. In this slide, we can see the environmental impact assessment with one-click LCA software, where information for different construction stages are presented from the pre-construction to the end, till the end of life of the materials. This is according to the European standard 15643. And here we have the results related to the life stages of the building, the construction materials, the transportation to site, construction installation processes, till the deconstruction of the material. Based on the specific process of exporting prices of environmental indicators, results were obtained basically for the 4 life stages of the building, which means the construction materials, the transportation to site, construction and installation, and the end of life. And here we can see the results of the assessment concerning the pilot case of Frederick University. In the first table, we can see the results for life cycle assessment, which include the life stages of construction materials transportation, construction, installation processes, and the end of life. The results are given for global warming potential, biogenic carbon storage, ozone depletion, and for fossil fuel resources and other indicators. And in the second table, we can see the results for site impacts, which only the assessment for transportation of construction materials was taken in consideration, because the rest were minus. In this last slide, we see the presented results of the indicators describing the usage of primary energy and water. It includes the use of net fresh water, a total use of primary energy, total use of non-renewable primary energy, the use of renewable primary energy resources as raw materials, and the total use of renewable primary energy results. As we can see from this assessment, it concluded that the construction 4.0, which is based on the digitalization of industry and industrialization of processes, could be used to achieve sustainability in the construction sector in general. And the integration of BIM and LCA could help in the sustainable renovation of non-residential buildings in the future, as well as in residential buildings. And in the future, more complex models would be needed to assess the sustainability and environmental assessment in all the life stages of products and materials. Thank you very much for your time. And if you have any questions, I'm here to answer them.
Thank you, Phoebe. Yeah. Alexander just asked something. Okay. Okay. So I will read it to you. I understand that the work with the...
Thank you.
Oh, okay.
I can see it. Thank you. The amount of is this one, right? Yes. The amount of environmental indicators seems very extensive. Thank you. I understand that the work with the BIM attributes plugin now provides ready-made tables covering elements and materials most often used in common buildings. Yes, we input the raw materials and what we have from the BIM from the BIM files and whichever information we have from the buildings and the users and the owners. And after the one-click LCA with the correct how it's called, with the correct combination of the materials, extract from this software, we extract the elements and the materials for these buildings. I'm not sure if I answered your question, but if I didn't, please let me know. Thank you. I would like, please, before I conclude with because before I didn't present it very well, regarding the operational rating energy performance of buildings, under this, the D2EPC project, and specifically with the help and effort of Mr. Basabe from UNE and Mr. Fokaidis from FRC University. They have started, they have initiated procedures for a new working group, for the creation of new working group on operational rating of of energy performance of buildings, and the votes are till August, the beginning of August, 8th of August. And should you have in mind any national standardization bodies, please vote for it, so the operational rating can continue on on what new can be conducted from the operational ratings. Thank you very much.
Thank you. So if there are no more questions, Mia is going to talk about the financial indicators.
Yes, let me share my screen. You see my screen, right?
Yeah.
Yes. Okay, so I will present the last indicators, the financial indicators. First, I'll start with the objective, so why we have decided to work on financial indicators. So we wanted to establish simplified indicators which will enhance the user friendliness of the building certificate. We wanted to develop a set of financial indicators based on the well-established concept of whole life cycle costing. We wanted to have interpretation of the individual elements of building energy performance as a monetary normalized values. And with that, we wanted to enable the employment of EPCs for the financial assessment of buildings energy upgrade measures. So we did this work in 3 steps. We started with the literature review, and then we continued with the methodology where we defined the financial KPIs. We looked how we can integrate them into the D2EPC architecture, and we did the calculation of the financial indicators. And the 3rd step was the development of guidelines for the D2EPC integration. Here we had a look at the real-life example of the Frederick building. We look at what kind of measurement data we can get from such a building, and we did an example. So starting with the literature review, just quickly going through, we reviewed the IEA EBC Annex 56, cost-effective energy and CO2 emission optimization in building renovation. We looked into the ISO standard on life cycle costing. We looked into the EN standard on sustainability of construction works, and then also the calculation methods. We looked at the previous work within the project that examined the aspects of the next generation EPCs, and we examined the levels scheme. So that was just quickly what was our foundation. But let's focus more on the methodology, starting with the definition of financial KPIs. So we wanted to provide users with a real-time image of the monetized performance of the building. And with the comparison of different scenarios, we wanted to allow users to allocate their performance of the building. But here the focus of the comparison is user behavior and his awareness of energy use, rather than the improvement of the building systems and the envelope. And finally, financial indicators will not affect the energy class of the building, but they will be presented as an additional information to the user. So the overall idea is that we looked at the as-operated energy consumption and translated it into the monetized values, and we compared that with the as-designed energy consumption, with the as-operated energy consumption in some past time, with the predicted energy consumption, and also comparison with the building stock. Finally, we wanted to see also whether the expected cost for the replacement and maintenance of the building system, so that the user can have an overview of the future costs. So how we can integrate that into the D2EPC? Looking at the D2EPC framework architecture, we have a service process layer that contains a calculation engine. This component is responsible for calculation to assess asset and operational performance. And within this component, we have subcomponents where the main one, building performance module, is responsible for KPIs calculation. And there are also two other subcomponents, one for asset rating and one for operational rating. So looking a bit closer, all the inputs are coming from digital twin. So they are based on the BIM literacy. And what we need for this building performance module to calculate the KPI, as mentioned before, we get outputs from the asset rating module and operational rating module, but some of the inputs are also required from the user. So with all this, the building performance module calculates the financial KPIs, which is the output. So how the calculation of the financial KPIs works. So first we need inputs. The most important ones are the costs. Operational utility costs are defined as cost of fuel for heating, cooling, power, lighting, water, and sewage. And since water and sewage costs are not related to energy, they're excluded from this calculation. And then from the asset rating module, we would need as designed energy consumption. From the operational rating module, we would need as operated energy consumption. And these are the inputs we need from the user. So we need price of the energy carrier. Here we decided that it would be a good approach if user provides this information, because that way we get more accurate results. But there are also different, let's say, tariffs approaches in different member states. So to get as accurate results as possible, it's best that this information is provided by the user. Then we also need information by the user for which energy carrier, which energy use is used for each energy carrier. We would also need from the user the average expected inflation and discount rate. Again, this is because it differs from country to country. And lastly, we would need building system information if this information is not already retrieved from the BIM model. And here we're talking about the installation date and price, the lifespan of the building system, the maintenance schedule, and the price. So then we can do the calculation of the as designed and as operated model. So this basically is just multiplying the energy consumption with the energy price, and the outcomes we can get from that is, let's say, for the as operated module, we can calculate the cost in euro per month per energy use, per energy carrier, and then the total cost in euro per month, per year, and per square meter. And similarly, also for the as designed module, we can get total cost in euro per month, per year, and per square meter. And then these two models can be compared between each other to see what is the difference between the as operated values and as designed values. Here it must be mentioned that the as operated yearly cost in euros is a true reflection of the monetized energy use in the building, but it does not match the bills that the residents receive because some additional costs like taxes are here omitted. Then next we have the prediction model. So with this one, we try to evaluate the future costs based on the inflation rate and the discount rate provided by the user. And we can calculate the real cost, the nominal cost, and the net present value. But it again needs to be mentioned that the comparison between the three values is an approximation, and it just aims to illustrate to the user the impact of time and the value of money they will be paying for the energy use in their building. Next thing are the expected costs for the building system. So here we just want to sum up the expected cost for the maintenance and for the replacement of the systems in the next few years, so that the user can have an overview of what are all the costs he can expect for the building systems. Lastly, the building stock. This is something that we can consider as a future exploitation because we would like to present the monetized energy use on an expanded, larger scale. So compare it with the building stock. And by using some filters and predefined criteria, the user could evaluate his performance of the building and compare it to the other buildings so he can allocate how well his building performs. Here you can see the list of all the financial KPIs that were just presented. So we have as operated costs, as a design costs, then comparison between the two, the predicted costs and expected costs for building systems. So with this, we concluded the methodology part, and we can go to the third step, which is the development of guidelines for D2EPC integration. As mentioned here, we had a look at the real-life example that was the same building that was just previously presented also by Phoebe, so the Friedrich University. It consists of lecture rooms, but also cafeteria, and it has a few input meter data loggers. It has 3 zone monitoring and remote sensors for CO2, temperature, relative humidity. And the measurement started last year in June, and that was also previously presented by Phoebe. So first, what we had to do was to examine what kind of data we can get from the measurements. This work was done in November, so it was only 6 months since the measurement started. So we still had to understand what kind of outputs we are getting from such measurements. But at that time, we concluded that the available data that we had was not sufficient for the initial calculation of the KPI. But nevertheless, it was really beneficial to understand what kind of data we get and what can we do with it. And based on that, the methodology we had was a bit adjusted so it could better fit the purpose. Nevertheless, we did the calculation with different kind of numbers, but just to showcase the whole process. And based on this calculation, we provided guidelines, a description of how this can be done. And with this part, we covered the third step. And to just quickly sum up, so our aim was to investigate the possibilities of integrating financial KPIs into the new generation EPCs, which will raise user awareness, provide additional information, and so improve the existing EPCs. The aim of actually all the KPIs is that they are user-friendly. So with these financial KPIs, we allow the users to better understand their energy consumption because we translate it into the monetary values, and such interpretation can be so much clearer and understandable to the user because they operate with money on a daily basis. And the outcomes is that user can compare the monetary value of actual consumption with the monetary value of the design consumption. He can get an overview of the predicted cost based on the inflation and discount rates, and he can get an estimation of future costs related to the building systems. So to conclude, what we currently have available in the current EPCs is that we already include some information about the monetary value of energy consumption, but that one is based on the design values. It usually covers yearly values, and the number of people it considers is an average, and it does not include the energy use of household appliances. While the financial KPIs within the D2EPC project, it shows the monetized value of energy consumption based on the monitored, so operational use. It gives an insight to the monthly values, and it reflects the actual consumption, so including the household appliances, and there is no need to estimate the number of people. And additionally, it also gives information about the predicted and estimated future costs. So that was all from my side. And if you have any questions, let me know.
Thank you, Mia. There's a question from Gerfried in the chat.
Are as designed costs corrected with degree days? Well, as designed costs are coming from as designed energy consumption, and this is part coming from the in the framework architecture from the, as mentioned before, from the engine. So maybe Stavros can have more information on that if he's still here.
Hello. Yes, of course. Can you please repeat?
So the question was, are as designed costs corrected with degree days? And what I answered is that as designed costs are coming from the as designed energy consumption. So maybe you can have more on that.
No, right now the methodology does not include degree day corrections, at least for the asset rating. Concerning the climatic data are consider the typical climatic values for each region, and when I see region, the climatic zone where the building is located, and there is no climatic data correction. I think this is the case for operational rating. Maybe Phoebe can also confirm this.
Sorry, what should I confirm? Sorry. Could you please repeat?
Yes, climatic data correction is also included in the operational rating. Is that right?
Yes, it is. Yes.
Okay.
Weather, yes.
Thank you, Phoebe. I think we have covered the question.
So see another question or a comment. You cannot compare as designed for standard year with as is from the last year. Is that a question or?
It goes with the reference building.
I think as this question is derives from Gerfried, it is an internal issue that means to be clarified.
Thank you.
Okay, so if there are no more questions, Stavros, since you have to present the web platform and the implementation of BIM Digital Twin.
Yes, let me share my screen. Okay.
We can see it.
Okay. Okay, let's swap the screens. And now I'm in presentation mode. Is that right?
Yes.
Yeah.
Okay.
Yes.
Okay. So, welcome back. Let's proceed with the overview. Firstly, we're gonna see the architecture overview of our system. And then we see the services provided to the user and the user interfaces. Then, as a case study, where I'm going to demonstrate the platform and see a live operation like an EPC issuance. And then we can have a short discussion like the previous one. So the system architecture, we have 4 layers. Starting from the bottom, we have the infrastructure or physical layer, where all the input data are received. The input data can derive from sensor devices or actuators, as well as more centralized systems like BMS and SCADA. And also we have weather data from APIs that collect them from various authorized internet sources. Then we have the interoperability layer, where all this information is processed and ensure an accurate result. And the third layer is the service or processing layer, where all the magic happens. Firstly, we have the BIM-based digital twin, where the building's information are structured and in a coherent digital model. Then each module from the above can call the required information to perform the calculations. In the calculation engine, like it has been already referred, there are 3 sub-modules. One is responsible for the asset rating, then there is for the operational rating, and all the KPIs that have been previously mentioned. The SRI, LCA, life cycle cost, and human comfort are calculated in the building performance module. On the green square at the left side, we also have the road mapping tool, which is responsible for providing all the necessary retrofit proposals. The AI-driven performance forecasts, which takes data, operational data, and performs the forecasting for energy consumption. And we also have the performance alerts and notifications. On the right green square, we also have the building energy performance verification and credibility, which performs the network monitoring and ensures the data quality. And also we have the building energy performance benchmarking, which compares the energy performance of the examined building with other buildings from the same category or the same locations, or according to which criteria we chose to. And finally, we proceed to the top presentation layer, where we have the web platform where all the information are presented, and the WebGIS, where we have more aggregated information presented for each location. We also have a mobile app, which is mostly used for performance alerts and notifications, and the credibility tool, which also provides notifications to the web platform. Finally, there is an objective to be connected with third-party platforms and tools. That's all. And the D2EPC repository is the place where everything is stored, from building information to past EPCs from the building, so we can have a historic data of the building. Now I would like to say a few words about the offered services from our platform. Firstly, the BIM-based digital twin. is a combination of the building's static and dynamic information. When we say static information, we have as a foundation the beam, level 3 of maturity, and up to the 6th dimension of beam model. And also we have several static information that has to be inserted by the assessor, like information about the SRI or an EPD for the LCA, which are not typically included in standard beam files. As for the dynamic information, we have the data from the sensors and meters installed from the building. I would like to clarify that when we say sensor, we refer to something that is inside the building and measures stuff like the occupancy or the air quality. And when we say meters, we are mostly related to power meters. We measure energy. And all the above information are included in a unified data model that includes all the required documentation for the various calculations in a structured and coherent format. Then the calculation engine performs the asset and operational rating, and the building performance module calculates the indicators to enrich the EPC procedure. The important thing here is we have ad hoc certificate issuing, monitoring, and verification. Proceeding to the road mapping tool for performance upgrade, the tool performs multiple strategic scenarios renovation and provides the customized recommendations for energy performance enhancement, taking into account the building and the user. To say a few more things about this tool, we compare the building's current state with the minimum requirements, and we provide the recommendations in a hierarchy list with firstly the measures that will upgrade our home's energy, our building's energy performance with the lowest cost. The AI-driven performance forecast module forecasts the building's operational conditions and the impacts that specific changes can have on the building's energy performance. Then it provides solutions for human comfort and energy efficiency. The indicated patterns that affect negatively the building's energy performance are shown to the user so he can advance his behavioral energy profile. The performance alerts and notification modules provides recommendations during the building's actual operation, and users have the flexibility to personalize their indoor environment. Users also take recommendations for daily operation, maintenance, and renovation. The Building Energy Performance Benchmarking module provides the necessary reference values for the building's classification. A classification engine indicates paths for performance improvements and provides insights also to the road mapping tool. Proceeding to the user interfaces, firstly, the most important tool here is the web platform, where we have a user-friendly and interactive environment where the user can adjust their performance, not his performance, his preferences, and request execution of EPC issuance and or any other calculation of the presented KPIs. In the web platform, we can see and issue an asset rating, an operational rating, the calculation of the KPIs. We can see which recommendations are applied to us to increase our energy efficiency, and receive alerts and notifications for possible malfunctions in the sensoring, metering equipment, or the technical systems of our building let's say for heating, cooling, etc. The environment design is user-centered, which means that the owner or the tenant or the engineer may access the web platform, but they can see different kind of information. Let's say an engineer can understand more stuff than the building owner. So for each user, we have specified information to be shown. The WebGIS tool presents a spatial representation of the building's energy performance data and visualizes the information layers using maps and 3D scenes. Also, it provides insights to market and authorities for informed decision making. Lastly, the alerts and notification mobile application is a user-friendly interface for technical alerts regarding the IoT operation. Now we can see a use case of how the platform operates during the asset rating issuance. Firstly, the assessor uploads the BIM file in an IFC format on the web platform. Then the file is redirected to the BIM-based digital twin module, and its information are passed from the dedicated BIM parser submodule. Then the retrieved information is validated by the input data validator, and the correction of any misalignments is requested through the web platform. The assessor completes the missing fields and requests the calculation of the asset-based EPC from the calculation engine. The command is transferred to the calculation engine, and the asset rating submodule analyzes the building's energy performance. Finally, the results are visualized on the web platform. And now I would like to present this procedure live. Okay, so this is our web platform. By going to the BIM Management tab, we can upload our BIM file. This is the file. Okay, so the file may contain some mistakes, or maybe it is not valid. So firstly, we have to proceed to a validation procedure. And as we see, there are several fields missing from the file. So me, as an assessor, or in the role of the assessor, I have to fill in the missing information. How to fill each field is described in the manual. To begin with, it is missing the building's type, so it is a residential building. The construction type is heavy. The coverage ratio of the technical system for cooling is assumed equal to 0.5. Okay. And for the sake of this presentation, we will assume all the coverage ratios equal to 0.5. No, here. Okay, the efficiency of a boiler, it is an electrical boiler, so it is assumed equal to 1. And again, some coverage ratio values, which are typical values not included in a BIM file. For the rest, solar collector, we're missing the orientation, which is south. The letter S is here, and its tilt is equal to 45 degrees related to the ground. So we submit the added information, and the validation procedure also runs in this case, validates the information that we just inserted, and now we are ready to calculate the asset rating. As we can see, our building has a top class A. Its ratio, the ratio of its energy performance to the energy performance of the reference building is equal to 0.17, and which is below 0.35, and that's why it is class A. And at the right side, we can see the visualization of the results. Firstly, we see the energy demand, and we can separate heating, cooling, domestic hot water, lighting, or have a total value. We are in Greece, so we have heating during the winter period and cooling during the summer period. And we have 2 months with neither heating or cooling, and domestic hot water is also added throughout the months, and as well as lighting. When go to the final energy, we can see the values for heating, cooling, and as I explained in the previous, in my previous presentation, we also have PV and solar thermal collectors energy provision. So the total energy, it is lowered by these two values. And then we have the primary energy, which are calculated according to the primary energy factor of each country. With this window, we can isolate several months that we want to examine, and either this way, either in this way, restore it, download the image, or we can see the values for each month. The values can be presented as a total value of kilowatt hours or as the kilowatt hours per square meter. Proceeding to the KPIs, we can see the total values, either kilowatt hours or kilowatt hours per square meter per energy carrier or per energy service. Here we have per energy service, so we have cooling, heating, domestic hot water, etc. And per energy carrier, we only have electricity, as we have heat pumps for heating, and everything works with electricity. And lastly, I would like to show the cost indicators for electricity. The total value is around 1,000 euros for the whole year. And we have the CO2 emissions for the annual operation. So now let's go back to the presentation and have a short discussion about the things that I presented. My first question is if you would like to have a 3D visualization of the building during the procedure, and how important it is for you to have it. Furthermore, the addition of extra information to the building model, how would you like to see the missing fields? Like the way I presented previously, each field one by one, or in a big table with the other information of the building parsed from the BIM parser. And do you like to have such an access to the information of the calculation results? Maybe you would like to have even more, to see even more calculations, like the transmission and ventilation, etc. calculations, or is it enough for you? Which is the best way to demonstrate the calculation results or values? Do you like the bar charts? Would you like pie charts or just plain values? And how long do you think a final EPC report should be, like in a PDF format? Or even if it is also a good practice to have a report, or do you think is it like obsolete and we need to proceed to more dynamic schemes? Thank you. I will have the last slide in presentation mode, and not in presentation mode, in the other mode, because I can see the raised hands. So, do you have any questions? Any answers to my questions? Okay, I see from Mr. Deligiannis, if I can see the build, 3D visualization is useful only to understand the potential difference of the model to the real building. Okay, thank you very much. Okay, no other comments. You could also provide me with your answers either in the chat or in the questionnaire that we delivered.
Yeah, I was going to say that since we are going to send the attendants the questionnaire with a manual, if they want to answer the questions on it, there's no problem with that. But I see that Alexander is, I think it's typing. It's answering each question.
All right. All right. Maybe any other colleague that would like to share his concerns. Okay. I would like to thank you very much. And I think we can proceed to the final presentation of the GIS.
Okay, thank you, Stavros. So now Christos is going to present the EIS platform.
Hello, everyone. Can you hear me now?
Yep.
Yes, we can.
Hello. It's a pleasure to participate this workshop also for the D2EPC project, and I will gladly present the advancements we have made for an additional service as part of the representation platform, the representation layer, as also Stavros earlier demonstrated. This is the WebGIS tool. I will start with the presentation. So please let me know if you can see my screen.
Yeah, we can see it.
Okay, perfect. And normally you can see now the
presentation
mode. Yeah. Okay. So let's start. I'm the last presenter today, so I hope that my session will be light. I will mostly focus on the live demonstration of the functionalities of the WebGIS tool. Well, also in the beginning, I will try to briefly describe the different implementation steps of the D2EPC GIS tool. Some use cases, the main actors and potential stakeholders that are involved and are mainly interested for such an application, for such a tool. its scope and functionalities. I will also present some technologies related to the implementation of the GIS, but not too much information about that. Of course, then at the end, we will proceed with a live demo and some open discussion if any of the participants wants to have more information about our service. So the overview of our component, it is important to state here that this service, this GIS tool, is not mainly directed to EPC assessors. So it's not something that EPC assessors or engineer will mainly get their hands on this kind of service, or we expect to have direct, at least, added value from the GIS. But indirectly getting the information that they are derived from the asset analytic calculation, as Stavros presented earlier, all this information will be fed through the dedicated geodatabase of the GIS, and all this information and enriched data will be able to be provided via graphs and statistics through the GIS, and of course in a spatial way. So the main business scenario for the WebGIS tool is the provision of regional level information and statistics for third-party stakeholders. So first use case can be the regional level visualization of the dynamic energy performance information for asset rating, the benchmarking and the comparison of different regions in terms of their energy performance state, and the statistics and the 3D model of the pilot buildings visualization. The main actors for this service are local authorities and registries and public bodies. There are also the companies related with the energy domain in order to know where more demand in energy needs comes from, and also building services industry in order to focus the provision of sales into specific regions and areas across Europe. But of course, other potential stakeholders that can be involved are researchers or academia, real estate agents, environmental or social campaigning organizations, standardization bodies, etc. Here are the main the main scope of the WebGIS tool. It is a tool that can provide information about EPC documentation across all European Union member states. It produces useful analytics and provide information regarding EPCs, and of course can provide insight and added value information services to give extra revenues to potential involved stakeholders. The main functionalities that I will later on present also via the live demo is, first of all, the production of EPC statistics. The second one is to visualize this information on the map via on selected regions. We have selected so far the official NUTS level information and administrative regions from not administrative, I mean NUTS regions from the European Union. We also provide spatial and attribute queries to the users. We can publish this information via OGC, common OGC services to other software for external and offline use. And the provision of and visualization of the beam model, 3D model, the simplified beam model on the map on an external pop-up window. The GIS place on the general D2EPC architectural schema is presented here. As I said earlier, is part of the representation layer and mostly analyzes the EPC data deriving from D2EPC repository and, of course, new asset rating data resulting from the calculation engine. Also, it is expected at the end of the project to be fully connected with the D2EPC web platform and be provided as an external service. The main functional diagram for this tool, it is based on three it is built on three main subcomponents that we have allocated as a front-end component, the back-end component, and the web server, the geo server installed. Of course, the front end is connected directly with the D2EPC web platform and is the main interface that the end user sees and interacts with. The backend component handles all the querying of data. It has also the connection with the database, the geospatial database, and the processes of the data, whereas the OGC web server delivers in OGC services this information, this data to the front end, but also to external users, as we're going to see later on. These are some the main technologies that we used for this implementation. To this end, we consider that this tool is finished as in terms of implementation, at least. Of course, there are a lot of integration aspects need to be done, but what we present here today is finalized in terms of the proof of concept of the functionalities of this tool. So we have created a separate database for the WebGIS tool. It is a geodatabase Postgres SQL with a PostGIS extension. It is one of the most widely used and well-tested databases in the world, and is also open source and free to use. We have selected, just a comment here, we have selected all these different technologies, mostly in terms of interoperability for future integrations and to be open source. For the front-end component, we used mostly JavaScript libraries and the Leaflet open source library to this end, and well-expanded plugins via React for also the user interface. And for the backend, we mostly used Python with Flask, and this was the optimal way, as we figured out, to connect the database with the backend, so the Postgres with the backend. All this information in the database again can be streamed through the web server, the OGC server that we selected to be GeoServer. Again, it is open source and free to use. So really quick, some snapshots from the interface of the WebGIS. This is the main, the first page, the home page of the tool. It highlights the project logo, some info area where I'm trying to have a pen. I'm not sure if you can see that, but it is okay. Some info area where the names of the region on top of which the user hover the mouse it appears. Some extra information. This extra information mentioned in the top right corner, we have selected so far to present the latest update of the database. So when a new EPC will be issued and through the common repository of the project will be integrated to the database, this will be highlighted there. On the left side is the main toolbar. We will go through each of the functionalities later on, and also some typical and common map controls. We have also different base map selections, so the user can navigate in different colors and base maps. There is some very similar and common as well. And lastly, we have the information about the website and the transition to the general D2EPC website. So first of all, some extra functionality that the GIS offers is the automatic zoom selector. As I said earlier, for the regions to provide the regions to provide statistics, EPC related statistics, we have selected NUTS from the European Union. So the first level 0 of NUTS is the countries. The second one is major socioeconomic regions. Of course, for those who do not know, I believe NUTS also is a combination of importance, but also population. So this is how these regions are determined. The level 2 are basic region for the application of regional policies, and for 3, the last NUTS level 3, are small regions for specific diagnosis. So for all these 4 different levels of layers, we can provide spatial EPC related information. This is a template, a sample of the for EPCs for the United Kingdom. To this end, of course, I have to let you know that all the information that are presented here are dummy data, are not real. But as a proof of concept, we have created some dummy data all across Europe in order to provide the functionalities of the platform and the GIS tool. We can also present and have some. This is the second use case, the comparison of the D2EPC status, the EPC status for 2 different regions or subdivisions or even countries. Spatial querying can be applied by naming through this specific functionality. So a user can search for a specific region to see the statistics, the EPC statistics to that region, and can have attribute querying as well by introducing and adding numerous of logical conditions. The final functionality of the GIS is the 3D BIM visualization. For this, for D2EPC, we will only integrate the pilot sites of the project as presented at the beginning of this workshop by Oscar earlier today. So this is the example of the smart house, the smart home of CERT in Thessaloniki. And this is the visualization of the NZ smart home. This is the last but not least. Also, we can provide this information, this spatial information through WFS OGC service to external software via this module. So an engineer could handle and to create his own maps to offline by exploiting this information provided by D2EPC, and this is an example in Quantum GIS software. So to sum up the presentation, the D2EPC GIS tool is a novel tool built from scratch for this project. It is built by using only open source tools exclusively. It is also implemented to be fully compatible with the other D2EPC components, the main web platform, and the respective dependencies. It can be also expanded with further extra functionalities. For example, display other statistics such as materials used. So we can more added value information can be extracted in a spatial manner, and offers easy integration using Dockerization methods and NGINX web server. So forwarding to the live demo session. I have, I hope you can see still my screen.
Yes.
Okay, we have here, it is offline to descent. This tool we will have firstly to be integrated to the general D2EPC web platform in order to be provided online publicly. So this is the main environment of the D2EPC. As I said earlier, it offers some main basic map navigation functionalities such as return to home, zoom in, zoom out. Of course, by rolling the mouse wheel also can offer this kind of functionalities. We can select a different base map in order to see better maybe the result or the produced graphs and plots. But today we'll stick with OpenStreetMap. First of all, as I said, the first thing that we can offer is some general EPC statistics on different NUTS level. That is 4 different NUTS levels. So, for example, by clicking on France, a pop-up window comes up with the percentage of different EPC ratings for France. By zooming more detailed and with higher scale, regions are presented, and we can see the information for the different regions. This is for the full European Union, including United Kingdom to descent. These are the official, and Turkey at least. I don't know if I also include some other countries, but it are the official data provided from Eurostat and the European Union. This is the first functionality. The second functionality is by doing that by querying. So a user may search the country that he wants. For example, first of all, selects the NUTS level. So the NUTS level 0 is the country level. Again, these are the functionalities as we have produced them, but if at a later stage for commercialization reasons or at the end of the project we decide that we need some other administrative regions, this is really easily can change to transfer, change from NUTS level to official administrative regions. So, for example, if I put Italia here, we can see the EPC statistics for Italy. The naming, it is again the official naming from NUTS, that it is a little bit tricky, to be honest, but comes also always in Latin characters. For France, it's this one, etc. If I change also the different the NUTS level to level 1, which is big socioeconomic and administrative regions, and I put ATT, again we will have the Attica region for Greece. Again, here it is presented the percentage of different EPC scores for this region. The next functionality, through querying, we can put some attribute querying through parallel logical conditions. So, for example, if I want to find all across Europe some extreme cases where we do find regions in, let's say, NUTS level 2, that we want to find the regions that present also a big percentage of A's and also F's. So, for example, to have a percentage of A score more than 20%, but also F score more than to 20%, we put that to end and we search. So it was indeed an extreme. I shift a little bit the percentage, and we can see the results of all the regions. Again, all these data are dummy data to this end, but we offer via the project, the D2EPC, the methodology, to incorporate real derived data, EPC data, to be to populate the respective database. I think that this is pretty straightforward. We can all understand that we can build more and more logical queries here and extract all the relevant information that may come in use. The next demo I would like to showcase is the comparison mode. So via the comparison tool, an end user can select 2 different regions of all across Europe again, and check the percentage and the score derived for the different EPC scores. So, for example, for a public authority, in order to provide some financial motivations or some funding opportunities to some specific regions, this will be really important to see which is the exact state of EPC of energy scores in different regions all across Europe, and make the respective comparisons. Again, I think this is pretty straightforward. Also, the 3D visualization of the simplified BIM file that can be uploaded. This is for the pilot cases so far. So, for example, for Thessaloniki and the smart home of CERT, by clicking this, its exact place is highlighted on the map, and by clicking on this cursor, we have and we can navigate in the 3D space to the BIM file that is uploaded. By clicking on a specific object and interface of the BIM, we can get above here the information of this exact element. So maybe this is also an additional feature for an engineer or for an EPC assessor to see that for a building that is responsible, that all the information are being put correctly together. Finally, last but not least, we can have some information about the project. This is not yet being incorporated, and we can also send some feedback via a specific mail. And also we have the OGC services. These are the OGC service links of the different levels of NUTS regions that I demonstrated. So, for example, if I take any of these WFS services and I use a common GIS or maybe remote sensing software, most of these software, such as the Quantum GIS, this is QGIS, is an open source GIS software. We can add this link as a layer. Putting here the respective link, and we can select the level of NUTS that we want. So, for example, this is for the level 2 NUTS region. So all this information from the D2EPC database now can be handled offline if we save as a vector file these features by anyone concerned, by an engineer or by an EPC assessor maybe. So offline we can handle this data and perform any kind of maps, export maps, or perform any further analysis. The information, as I said, can be provided here, and it is really intuitive. It offers all the numbers and the percentage of different score of each region. And for example, we can thus, let's say that we want to provide a heat map or a scale of the maps for how many A+ scores we have for all across Europe. It is something like that. Of course, this is again dummy data, are not correct, but you get the idea and the functionalities that can be provided, all the information that can be provided and extracted from such a service. So that was all from my side. I will see the chat. Either know any comments? Oscar, can you help me on that?
Yeah, there's no comments on the chat.
Okay. So, Oscar, the floor is yours. Thank you very much.
Thank you. So, as this was the last part of the workshop, just remind you that we are going to send you a questionnaire in your native language, so it's easy for you to answer, and also the manual, okay, the manual of the EPC assessor. So if there is no further comment from the partners of the project, we can finalize the workshop here. Okay.
Thank you very much for all the presenters.
Thank you again.
Bye.
Bye-bye.
Thank you very much,
Thank
everyone,
you.
for participating.
Bye-bye.
Thank you.
Bye-bye. Bye-bye. Thank you, Oscar.
Thank you.
Bye.
Bye-bye.
Thank you. Bye.
Goodbye.